Part 3 of trigonometry involves what we call the sine law. We use this law to solve triangles that do not have right angles, and it's a very simple law to use. The length of any side divided by the sine of the angle across from it is constant. So any of these three ratios are equal. Also, we can turn these over. If these are equal, then the reciprocals are equal. If you're new to trigonometry, you're probably thinking, well, where is the sine? Where is the opposite? Where is the hypotenuse? So I'm just going to go through a little development here just to show you where this comes from. What I've done is taken the triangle and I've drawn a height from C. And in this case we have two right angle triangles, and now we can see the sine of A, opposite over hypotenuse, that's h over b. And over in this right angle triangle over here we can see the sine of B, again the opposite over the hypotenuse. And when you write that down and you cross multiply, which gives us b sine A equals h, and the same thing over here, these two h's are equal. So if the h's are equal, then b sine A is equal to a sine B. And if we divide both sides by A and by B, cancel the b's here and the a's there, we end up with the sine law. So even though we can't see the opposite and the hypotenuse in the drawings that we're working with, it's still a valid formula. So here's an example of a triangle. We've been given two sides and one angle. Now what you have to do here is you have to be able to match an angle with the side across from it. So I know I'm going to use the 70 and the 25. Since I have the side here which is 20, I'm going to solve for the angle across from the 20, which is angle B. So this is how I set it up. The sine of B over 20 is equal to the sine of 70 over 25. It's very easy to set this up. All we have to do is cross multiply 20 times sine 70. We get the answer for this on our calculator, and then we use the inverse sine button in order to take the inverse of this answer, and that will give us angle B. To get angle C then, very simple, you just subtract the 70 and the 49 from 180, and that'll give you angle C. Now what I've done over here is I've redrawn the diagram with the information that I have so far. I have the 61, the 49, and the 70. The only thing left to find is side C. So this time I'm going to put that on top. I always like to put the unknown on top, then I have fewer things to move around. So I'm going to put C over sine 61 equals, again, 25 over sine 70. Cross multiply, bring this sine 61 up here, put that into my calculator, and that gives me the length of C. It's a very simple formula to use, and you notice here I put the sine on top because I was solving for the angle, and over here I put the side on top. It just makes it easier when you go to solve for it. One more example. Sometimes when students look at a triangle like this, they think, oh, I can't use the sine law because I don't have the side across from the 60. I don't have the side across from the 80, and I don't have the angle across from the 12. But don't forget, if I subtract the 60 and the 80 from 180, I will have the size of angle C. And then I can get started because I have this angle matched with the 12. So then it's up to you which side you want to solve for. I decided to solve for side A first, so I put A over sine 60 equals 12 over sine 40. And again, I just cross multiply, put it in my calculator, and I've got A. If you want side B, put the B on top. B over sine 80, again, equals 12 over sine 40. Cross multiply, and there's B. It's actually easier than some of the right angle triangles because there you had to try to figure out, am I going to use sine, cos, tan, what's the opposite, and so on. Here it's always sine, and you have a nice simple ratio each time. Now just one final thing I want to mention before I close here. There are two triangles where you cannot use the sine law. If you're given three sides, or two sides and the angle between them. Because if you've got three sides, you've got the bottom of each fraction here and you can't get started. In this case, you have a side, this angle, and that side. And again, you can't get started with the sine law. And you need the cosine law to do those. And that's what I'll look at in the next video.